Hey students, let's solve one previous question of discrete math. This question was asked in GATE CS 2025 set 2 question number 5. Let P of x be an arbitrary predicate over the domain of natural number. Which one of the following statement is true? And 4 options are given. Now all the options are based on implication. In case of implication, true implies false is false, rest all true. In question it is asking which of the following statement is true. So what we'll do, we'll try to make it false. If it can't be false, then it is true. For making it false, we need to make this as a false and this as a true. So true implies false will be false. Now for option A, we'll consider for all x px as false. This is our consequence, and p of 0 and for all x p of x implies p of x plus 1 as true. This is our hypothesis. Let's consider p of 0 is true. Now in case of true is true, rest it is false. True and false is false, false and true is false, false and false is false. Now p of 0 is true for all x. P of x implies p of x plus 1. Start with p of 0. P of 0 is true. So p of 1 will be true. Left side is true. To make whole implication true, this p of x plus 1 should be true. For p of 0 is true, p of 1 is true. For p of 1 is true, p of 2 will be true. For p of 2 is true, p of 3 will be true. Like this it will continue. Hence we prove that for all p of x true, p of x plus 1 is also true. Contradict this assumption that for all x p of x is false, as we prove for all x p of x is true. When this is true, this whole implication is true. We can't prove that for all x p of x is false, as this is not false and it is true, so whole implication is true. Whether left side is false or true. False implies true is true. True implies true is true. Hence option A is true. Next we'll check option B, p of 0 and for all x p of x implies p of x minus 1, implication for all x p of x. So we'll consider this as false for all x p of x and this left side as true. So true implies false will be false. Now let p of 0 equals to true. So p of 0 is true. Next p of x implies p of x minus 1. So we'll start with x equals to 1 for whole implication to be true, and p of 0 is true, p of 1 can be true or false. We know right side is true if left side is true or false, whatever, this whole implication will be true. This is our p of 0, this is our p of 1. Okay, p of 0 is true, p of 1, whether it is true or whether it is false, this whole implication will be true, right? So it is not guaranteed that p of 1 is true. Let p of 1 and p of 2. If p of 1 is false, p of 2 may be false. So false implies false is true. Hence it proved that for all x p of x is false, as some x value are false. For some k, p of k is false. So for all x, p of x is false. We proved that this right side for all x, p of x is false. If left side is true, then whole implication will be false. Next option C, p of 1000 and for all x, p of x implies p of x minus 1, implication for all x, p of x. This proof will be same as option B, as option B is false, option C is also false. You can consider initially this as false. We'll try to prove this left side as true. So first consider p of 1000 as true. Next for all x, p of x implies p of x minus 1. So p of 1000 is true. This will be p of 1001 because this is x minus 1. This is true. This may be false. False implies true is true. Next p of 1002 implies p of 1001. So this is false. This is false. Whole implication will be true, right? Hence we found that for all x, p of x is false. There are some k for which p of k value is false, as this is false for all x px. If left side is true, then true implies false is false. Next option D, p of 1000, and for all x p of x implies p of x plus 1, whole implication for all x p of x. Let this as false. We'll try to check for the left side can be true or not. So first we'll consider p of 1000 is true. P of 1000 is true. Next, for all x p of x implies p of x plus 1. So p of 1000 is true implies p of 1001. To make whole implication true, if this is true, this should be true. As true implies false will be false. Whole implication is true. P of 1000 is true. So P of 1001 is true. Now P of 1001 is true. This means P of 1002 is true. Like this it will continue. Hence for all x p of x whose value are greater than 1000, this is true. But what is x? X can be any positive natural number. So when x value is less than 1000, this may be false, right? Hence for all x p of x is false. This is true for all x value greater than or equals to 1000, but this might false when x value is less than 1000. And for all x px means for all x value, x is any natural number. As right side is false, if left side is true, this whole implication will be false. Answer will be option A, p of 0, and for all x p of x implies p of x plus 1, whole implication for all x p of x. If you compare option A and option D are similar, just here there is p0, here is p of 1000. So after 1000 for any x value, this is true, but x value may be less than 1000. For that, for all x p of x may be false. But in option A, it's starting from 0 and all natural numbers start from 0. All positive numbers are greater than 0. That's why option A is true, but option D is false. In case of implication, true implies false is false. So in all the proof, we assume right side is false, left side is true. If we cannot make this as false, then this is true. If we cannot prove that this right side for all x p of x is false, then this is true. I already discussed predicate logic. Just go through the lecture, and if this lecture is helpful for you, please like, share and subscribe. Thank you. Bye bye.